Now we are going to solve the fifth problem. If a light of wavelength 330 nanometer is incident on a metal with work function 3.55 electron volt, the electrons are emitted. Okay. The wavelength of the emitted electron is. So the four conditions are given. We already know what is photoelectric effect. So Einstein's photoelectric equation we are going to use here also. Before that, the given quantities I will write. So what is the incident wavelength? The incident wavelength lambda. Okay. So incident wavelength lambda is equal to 330 nanometer is 10 power minus 9 meter. Nanometer is 10 power minus 9 meter. Okay. Then what is the work function? You see 3.55 electron volt. So the work function phi naught is equal to 3.55. So this is 3.55 electron volt. So 1 electron volt can be converted into joule. So in joule, 1 electron volt is equal to how much? 1.6 into 10 power minus 19. So this is also equal to how much? 3.55 multiplied by 1.6 into 10 to the power of minus 19. Now the unit has become joule. So if you multiply means the value will be nearly equal to 5.68. So this is equal to 5.68 into 10 to the power of minus 19 joule. Okay, students. So now what is the photoelectric equation? The incident energy Hc by lambda is equal to work function phi naught plus half mv square. Okay. So now kinetic energy is also now equal to what? The incident energy. Okay. Hc by lambda minus work function. This is Einstein's photoelectric equation only. Is it not? This minus phi naught is taken to the left side means what? Work function plus kinetic energy is equal to the incident energy. Therefore, what is the kinetic energy? The kinetic energy of the photoelectron must be equal to the incident energy Hc by lambda minus work function. So all the values are given. I am going to substitute. Okay, students. So H is the Planck's constant. So this is now equal to what? First factor is what? H into C. What is H? H is what? 6.6 into 10 to the power of minus 34 multiplied by 3 into 10 power. Okay, 3 into 10 to the power of 8 divided by lambda is how much? Okay, this is also equal to what? 330 into 10 power minus 9. So I will take minus 2 power from here. This can be written as what? 3.3 into 10 to the power of minus 7 meter. So in the denominator now it is 3.3 into 10 to the power of minus 7. I am adjusting the terms. Now 6.6 divided by 3.3 is how much? 2. Easy calculation, is it not? So I can cancel these two and I can write it 2. So 2 into 3 is how much? 6. Is it not? So minus, this is first factor. Okay, minus phi naught. Instead of phi naught, I can write this is 5.68 into 10 power minus 19. So this is now equal to the first factor is what? This 6.6 and 3.3 cancel. Remaining factor is 2. 2 into 3 is 6. So 6 into, now 10 power minus 34 is here. This 10 power minus 7 will come up as 10 power plus 7. So that 8 plus this 7 will become 15. So the remaining powers will be what? 6 into 10 power minus 19. Easily it is going to cancel, isn't it? See here, common factor is 10 power minus 19. Such powers only will come. Suppose 10 power minus 18 is coming means it is a hint that you are doing some mistake. So in such problems, easily cancelling and adjusting numbers only will come. That is the hint. So this minus 34 plus 8 plus 7 will become minus 34 plus 15. That is equal to minus 19. Okay. So minus 5.68. So minus 5.68 into 10 to the power of minus 19. So my dear students, 10 power minus 19 is a common factor. So 6 minus this 5.68 will be how much? 0.32. Easy to subtract. So this is equal to what? 0.32 into 10 to the power of minus 19 joule. Joule is the SI unit. We have converted the electron volt into SI unit, namely joule. Okay. Now, what is asked here? The wavelength of the emitted electron means which wavelength? It is a de Broglie wavelength. So, now the de Broglie wavelength of the electron, lambda electron, is equal to h divided by square root of 2m into E kinetic. 2m into E kinetic. This equation we have derived in the theory class. Okay, students. So, instead of E kinetic, what symbol also we have used? Small e into capital V. If V is given. But if kinetic energy is found or given means, we can substitute directly the kinetic energy. Because lambda is in meter, h is Planck's constant in SI system, and mass in kilogram if you substitute means E kinetic should be in joule. So I am going to substitute. So this is equal to h divided by, so this is equal to 6.6 into 10 to the power of minus 34, and this is divided by square root of, it is a lengthy calculation only, we have to do it. So we have to practice. So this is 2 into 9 into 10 to the power of minus 31, because the square root of 9 means it is easy 3. Instead of 9.2, I am assuming it is 9 itself. Nothing is going to happen. So it is accepted. Into. So what is the value of kinetic energy we have got already? 0.32 into 10 power minus 19. So this is 0.32 into 10 to the power of minus 19. Understand? So we are taking the square root of the denominator. So now you see that this is 9 2s are 18. 18 into 0.32. So 18 into 0.32 means it is a number less than 18 only. We have to take a calculator and find out. So I am going to use the calculator. Understand? So 2 into 9 into 0.32. I am going to do now. So 2 multiplied by 9. Okay. Into 0.32. Okay. 0.32. So I have found the answer as 5.76. Okay. So this is now inside the square root. You see here lambda e. So therefore lambda e is now equal to 6.6 into 10 to the power of minus 34 divided by square root of. Okay. I told you use the calculator and find out. Okay. It is 5.76. Okay. 5.76. into 10 to the power. Now see here, minus 31 and minus 19, if you add means how much will come? Minus 50, easy to calculate. So this is equal to what? Minus 50. Okay. And this is now equal to, so this is now equal to 6.6 into 10 to the power of minus 34 divided by square root of. Now 5.76, if you multiply this by 100, it will become how much? 576. 576. So that here the power will become now how much? 10 power minus 52. 10 power minus 52 is an even number. No, 52 is even. If you take square root means what number will come out? 10 power minus 26 will come out. That is the logic. Similarly, 576, why I should multiply by 100? Because 576 is a square number. 24 square. 24 square is how much? 576. So this is now equal to 6.6 into 10 to the power of minus 34 divided by square root of 576 is what? 24 multiplied by 10 to the power of minus 26. Okay. So this is equal to, now it is 6.6 into 10 to the power of minus 34 divided by, okay, I will adjust the 10 powers first. Okay, I will adjust the 10 powers. So here also I am going to use the calculator now. So 10 powers if you adjust means it is 6 point, okay, 6.6 divided by 24 into 10 to the power of, this is minus 34, this is plus 26. So it is 10 power minus 8 will come. So this is 10 power minus 8. Understand? So if I will use the calculator once again means, so 6.6 divided by, okay, 6.6 divided by 24, okay. So this is 24 divided by 24. So I get this is equal to 0.275. Understand? 0.275. You can verify now. You can check. So this is equal to 0.275 into 10 to the power of minus 8 meter is coming. Okay, students. Now I will adjust the decimal place such that this is 2.75 into 10 to the power of minus 9 meter. So this is also equal to what? 2.75 into 10 to the power of minus 9 meter. So what is lambda E here? That is the de Broglie wavelength of the emitted electron. What is the incident wavelength given in the problem? 330 nanometer. Okay, students. Now, do you remember what is the threshold frequency? Threshold frequency is the minimum frequency, okay, of the incident radiation below which no emission of electrons will take place, or the wavelength corresponding to threshold frequency is called as what? Threshold wavelength. That only is called lambda naught. Is it not? Okay, so this is the maximum wavelength, okay, of the incident radiation. For this wavelength, maximum wavelength, okay. Now what is the de Broglie wavelength of the electron emitted? We have calculated. So any wavelength greater than this 330 nanometer cannot emit the photoelectron. Understand? So this wavelength itself, 330 nanometer, has emitted a de Broglie wavelength of this much means any other wavelength less than this 330 nanometers incident on the metal means naturally the wavelength of the electron, the de Broglie wavelength of the emitted electron must be naturally greater than this value only. Understand? Therefore we can write the de Broglie wavelength of the emitted photoelectron must be greater than or equal to 2.75 into 10 to the power of minus 9 meter. This is the option. So which of the four options is got by us? Now you see here. So this is greater than or equal to. So option B must be the correct answer. So option B is correct. Have you understood, students? Shall we go to the next problem? Okay.